Welcome to Penrose Learning, where we make understanding easy.
You begin by verifying hardware compatibility. Make sure the camera module exposes a control interface like UART, SPI, or I2C. Next, pick a Bluetooth radio, BLE for low-power streaming or Classic for simpler serial bridging. Choose a module such as NRF 52840 or HC05. Once chosen, prepare an ESP32 microcontroller and power source, and wire a basic breadboard layout. While you set up tools and connectors, note voltage levels and ground commonality so signals won't damage components. Once hardware is wired, flash firmware onto the ESP32 that includes the camera driver and Bluetooth stack using Platform I/O or Arduino IDE. Implement a robust control protocol. Write a command parser that triggers capture, buffers image data, and fragments frames into Bluetooth packets. Make sure to compress images with JPEG and tune quality to balance latency and fidelity. Adjust MTU and packet size to minimize fragmentation. While testing, add flow control so the receiver can request retransmit or pause streaming when overwhelmed. To finish, pair the Bluetooth module with your phone or PC and perform short test streams to validate timing, memory, and stability. Deploy the camera into an enclosure, address heat dissipation, and enable power-saving modes for battery use. Make sure device wakes reliably. For final firmware, implement a reconnection routine and persistent settings. If you hit dropouts, check MTU settings and Bluetooth link quality. Reduce JPEG quality to lower bandwidth, and add acknowledgement plus retransmit logic so you recover lost packets.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.